Hello everyone, welcome back to our channel Everyday Learning. So in today's video of digital logic design, we are going to understand a bit conceptual knowledge about ROM, and then we are going to learn how can we program a ROM according to a given pattern. At first, let's understand in brief about the basics of a ROM. A ROM is a non-volatile memory and stands for read-only memory. So a read-only memory is essentially a memory device in which permanent binary information is stored, which indicates we cannot erase or modify or update any information existing in the RAM. And then the binary information must be specified by the designer and is then embedded into the unit to form a required interconnection patterns. This is explained in the sense of designing and programming the ROM. Then once the patterns are established, it stays within the unit even when the power is turned on and off again, making it a non-volatile memory. Even if we turn off the computer or the device, unlike RAM, the programs inside it will never be erased. So a ROM kind of looks like this whenever we express it in terms of block diagrams. We enter input using addresses, or we enter addresses and we get the data from that particular address as output from the ROM. Now let us see how can we program a ROM from a given truth table and design its logic diagram. So we are given the truth table here, and according to the truth table we have a 5 to 32 decoder which will help us to form our ROM, and to establish the connection we'll indicate with X. So X in our diagram will indicate connection. So let's start from A7. We can see that the pattern is 1011 0100. So at points we will put on X to represent connection. So we can see that from 0 to 3, 0, 1, 2, 3, we have 1, 0, 1, 1. So here we'll give one cross, here nothing as there is no connection indicated by 0, and then again 1, so we have a connection X, and again a 1 connection X. And then we are coming to 28, we have 0, so no connection, and then we have 1 connection indicated by X and remaining are 0. So for A7 we got 1, 0, 1, 1. We have got 1, 0, 1, 1, 0, 1, 0, 0. Now moving on to A6, we have 0, 0, 1, 0, and then 0, 1, 1, 0. Moving on to A5, we have 1, 0, 0, 1, 1, 0, 0, 1, and then 0, 1, 0, 1, 0, 1, 0, 1. Moving on to A4, we have 1, 1, 0, 1, 1, 1, 0, 1, and then we have 0, 0, 0, 0, 0, 1. Moving on to A3, we have 0, 1, 0, 0, 0, 1, 0, 0, and then 1, 0, 1, 0, 1, 0, 1, 0. Moving on to A2, we have 1, 1, 1, 1, 0, and then we have all other remaining zeros. Coming to A1, we have 1, 0, 0, 1, 1, 0, 0, 1, and then 0, 1, 1. And finally for A0 we have 0, 1, 1, 0, 0, 1, 1, 0, and 1, 0, 0, 1, 1, 0, 0, 1. Alright, so this is how we can establish the connections using decoder and OR gates for our ROM. This is how the connections are established, that is the patterns are established, and it stays within the ROM even when the power is turned on or off as many times as required. Let us consider we have an address here like this, 1, 0, 1, 1, 0, 0, 1, 0. So this address, this particular address, let me mark with highlighter, this particular address is saved here. It is saved here. And this address, as it is saved, will stay inside this designed ROM even if the connection is cut off a couple of times. This is known as a permanent storage using fuse link. So this is how we can use the prepared truth table for any particular function to design a particular ROM for our digital devices, and I hope you could understand the basics about ROM and how to program it from truth table. If you have any confusion related to this topic, feel free to write down below and we'll get back to you. Thank you for watching this video.